Before testing your conductivity with your vernier probe, there's a few precautions you might want to consider. Although conductivity testing is a relatively safe procedure, it never hurts to be too careful. You're going to want a pair of safety glasses, a pair of gloves, and of course, your fancy lab coat. For this lab, you're going to need a few things. First, the LabQuest module, the vernier probe, the DI water, the 1000 microsiemens standard solution, and of course the analyte you're going to be testing the conductivity of. To do a calibration, first select the detection range on your vernier probe. Next, click the readout. Select Calibrate. For a 2-point calibration, make sure 1 point is not selected. Select Calibrate now. Dip the vernier conductivity probe into DI water. Be sure to submerge the entire electrode, but don't go too deep because the handle is not waterproof. Enter a value of 0 microsiemens. And select Keep. Next, dip the vernier conductivity probe into the supplied standard 1000 microsiemens solution. Enter a value of 1000 microsiemens. And select Keep. Then select OK. Your vernier probe is now calibrated. Now you're ready to test the conductivity of your sample. Once your LabQuest module is calibrated, insert vernier probe into your desired analyte. Look at your LabQuest module and record conductivity. Wash off with DI water between each measurement. If properly calibrated, your conductivity probe should give you the same reading.
A conductivity probe consists of two main parts: the anode, positive for a power-consuming device, and the cathode, which is negative. The cathode is usually made from an inert material such as graphite. This is placed into the solution in question, with the other end connected to a measurement device such as a computer. The probe is activated when a voltage is applied to the system. This puts force onto the charged ions in the solution, which pushes them to either side of the anode or cathode depending on their charge. Negative electron-carrying ions move toward the anode. Positive electron-less ions move towards the cathode. Their electrons are taken from them, and they become positive and start moving toward the negative cathode. At the cathode, they are given an electron, and the process repeats. What the computer measures is the conductivity of the solution by measuring the amount of current proportional to the ion concentration when a potential difference is applied between the two parts of the probe.